All right, everybody, welcome to the video for lesson number 8 on solving linear systems. This is solving linear systems with 3 variables, so slightly different from what you would have done way back in Algebra 1. So first thing we want to do is we want to create a couple workspaces. So the workspace is just giving us a space that we can do some different things like adding certain equations together. Now, before we move forward, we have to figure out which variable we want to get rid of. So I'm going to choose the variable x. The only reason why I'm going to choose the variable x is they have numbers that are kind of favorable to us. 2 can be multiplied by 2 to make 4. 2 could be multiplied by 3 to make 6. Also, some of them are negative and some of them are not. So the first thing I want to do here is I want to take the last equation, negative 6x minus 2y minus 8z is equal to negative 50. And I want to add that to the first equation times 3. So 2 times 3 is 6x. 3 times 3 is 9y. That's an x. And 3 times negative 2 is negative 6z's. And 3 times 33 is 99. X's cancel. I'm left with 7y minus 14z is equal to 49. Nice thing about that is everything there has a common value of 7, so I could turn that into y minus 14z, not 14, 7 divided there would be a 2, is equal to just 7. You don't have to do that stuff, but it'll just make everything smaller numbers. So I've used the first equation and I've used the last equation. And what I've yet to use is the middle equation. So I'm going to write that one down over here. I'm going to leave it just as it is. And I'm going to multiply the first equation again, but this time I'm going to multiply it by negative 2. So that's going to give me negative 4x, which we want, so they cancel. That's going to give me negative 6y. And that's going to give me a positive 4z. Is all equal to negative 66. X's cancel. I'm left with negative y plus 7z is equal to negative 12. All right, so the nice thing here is the y values already cancel. So the y's cancel. I'm left with 5z is equal to negative 5, or z is equal to negative 1. So now that I know z, I can find y. So I know negative y minus or plus 7 times negative 1 equals negative 12. So negative y minus 7 is equal to negative 12. Add 7, y winds up being positive 5. Last leg, I plug into the original equation, so I have 2x plus 3 times 5 minus 2 times negative 1 equals 33. Combined up some like terms there, I get 2x, 15, and 2 is 17 equals 33, or x equals 8. Remember, from class, you can also check these right on your calculator using a matrix. There's a separate video showing you how to do that. Number four is a little interesting. All right, so number 4 gives us an opportunity here to get rid of r right away. So if I do 2p plus q minus r equals 8, and q plus r equals 4, the r's cancel, which leaves us with 2p plus 2q equals 12. All of those could be divided by 2, so I have p plus q equals 6. So I've used the first equation and the second equation. I've yet to use this one. So if I do p minus q equals 2, well, I could either add it to one of the 2 equations we've already used, or if I'm really smart, I can add it to this one. Why? Because the q's cancel. Remember, our job here isn't necessarily to just keep using the same equations. It's to get to something that's solvable, which that is. Now I know p is 4. Well, if P is 4, I can say P minus Q is equal to 2, and I could say then 4 minus 2 is equal to 2, so Q is equal to 2. Right, that's how I did that. If I know Q, I can then find R, so I could say 2 plus R equals 4. So what's R going to be? Well, R is going to be 2. Now, if you were thinking about how to put that into the matrix on your calculator, so you have a 2, a 1, a -1, and an 8, you're going to have a 0, a 1, a 1, and a 4, and you're going to have a 1, a -1, and a 0, and a 2. Just replace the missing P and the missing R there, and you could go with that. Number 5 says show that this is a system without solving the system. So all you have to do is plug in x, y, and z for x, y, and z in all 3 of these equations. So I'm going to say 10 plus 2 times 4 plus 7 equals 25, or 25 equals 25. That works. I'm going to say 4 times 10 minus 4 minus 5 times 7 equals 1. 1 equals 1, so that checks. -2 times 10 minus 4 plus 8 times 7. That's a 7, not a 4, Serbino. And that's all equal to 32, which also checks. That's all it's asking you to do, right? If you want to solve it, you can. Be my guest. Number 6 says, in the following system, the value of the constant c is unknown, but knowing that x is -8 and y is 4, the x and y values are solved in their values that are solutions to the system. Determine the value of c. Well, if you know x and y, you only need this equation alone. So if I know x, I can say 2 times -8 plus, or not plus, minus 4 plus CZ is equal to 35. I can say -16 minus 4 plus CZ is equal to 35, and I can move this -20 to the other side and see that CZ is equal to 55. Right, I would add 20 to the other side. Problem, I have 2 variables, C and Z. C I don't know, and I'm not going to know. That's what I'm solving for, which must mean that I can solve for Z in some way. Well, if I know X is -8 and Y is 4, I can then use a different equation and solve for Z, because there's only one variable now. So then I have this -12 plus Z equals -1, or Z is equal to 11. Well, if Z is equal to 11, I can then say this is 11C equals 55, or C is equal to 5. That's what it's asking you there to do in number 6. Hopefully this video helped. Make sure you're studying for your test on Friday.